Hello, Chem 130 students. You should have just watched some videos of my hands drawing some Lewis dot structures for you. So now that you've seen several, I want you to practice some on your own. I want you to try to do Lewis dot structures for NH3, HCN, CHF3, and CO2 with the center atom being underlined. So hit pause. All right, and we're back. NH3 ends in the center. We have 3 bonds to the hydrogens. Were they single bonds or one single, one double? What did it look like? Did you add up your valence electrons? That's the first step, right? Well, hopefully you did it correctly, and it looks like this. So when we add up our valence electrons, nitrogen has 5. Hydrogen has 1, but there's 3 of them, so 1 times 3 is 3. 5 plus 3 is 8. We have 8 electrons, valence electrons, that need to be in our drawing. Now we start out with nitrogen in the middle and start out with single bonds to the hydrogens. Now remember, all the atoms in the picture need to have 8 electrons around them, except for hydrogen only needs 2. Look at those hydrogens. So the hydrogens have 2 around them because of the bond. The bond is 2 electrons. 1, 2. 2 electrons in this bond, so hydrogen has 2. The bottom hydrogen also has 2 because of the bond. And this hydrogen has 2 because of the bond on the right side. So the hydrogens are all good. Now the nitrogen has 3 single bonds around it. Bonds contain 2 electrons, so 3 times 2 is 6, plus the 2 electrons on the top as dots makes 8. So nitrogen has 8 electrons around it. All right, so everybody's happy. Now, does the whole picture add up to 8 valence electrons? Well, 1, 2, 3, 4, 5, 6, 7, 8. Yes, it does. There are 8 total valence electrons in the picture, which adds up to what we added up at the beginning. So that worked out well. That is the correct structure. Now let's look at HCN. Oh, we have a triple bond between the C and the N. Yeah. If you tried single bond there, it didn't work. If you tried a double bond there, it didn't work. We needed a triple bond between the C and N. Let's look. C is in the middle. We have H on one side with a single bond because hydrogens need 2. That's just a single bond. That's it. You can't double or triple to a hydrogen. Now the nitrogen's on the other side. Now the carbon and the nitrogen both need 8 around them. Let's look at the carbon in the middle. It has a single bond on one side, which is 2 electrons. Has a triple bond on the other side, which is 6 electrons. 6 plus 2 is 8. There are 8 electrons around the carbon. Now the nitrogen also has the triple bond around it, so that is 6 electrons, plus it has 2 dots. 6 plus 2 is 8. So the nitrogen also has 8 electrons around it. So everybody's happy. Now let's check our valence electrons. When we add those up at the very beginning, which is the first thing you do, hydrogen is 1, carbon is 4, nitrogen is 5. So that makes 10 total valence electrons. Let's see if there's 10 in the picture. We've got 2 in the single bond, 6 in the triple bond. That makes 8. 2 dots, 9, 10. 10! Worked out perfectly. Great. All right, CHF3. There it is. Now, if you drew the H on the left side, the right side, or at the bottom, that's okay. It's just rotated. So that's okay if you did that for that Lewis dot structure. I just happened to draw the H on top. All right, let's add up our valence electrons. Carbon has 4. Hydrogen has 1. That makes 5. Plus fluorine has 7 times 3 is 21. 21 plus 5 is 26. So remember, 26 electrons is what we need in the drawing. Now, let's put it together. Carbon's in the middle. We have an H and 3 F's, so 4 atoms around the H. So we start with 4 single bonds to an H, an F, and a third F. Now make everybody happy. Hydrogen can only have 2. So hydrogen is happy with a single bond. Again, you cannot double or triple bond to a hydrogen. Just a single bond, that's it. The fluorine has a single bond between it and the carbon. So that's only 2 electrons. So it needs 6 more. So we draw 6 dots around the fluorine. All the fluorines are the same. So they all have 6 dots. That makes them happy. They have 8 electrons around them total. 2 in the bond, 6 in the dots. The carbon has 4 single bonds around it. Those are 2 each, so 8 electrons around the carbon. The carbon's happy. Everybody's happy. Now let's see if it's 26. Count up the electrons. Remember, there's 2 in a bond. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 25, 26. It matches. 26 is it. Single bonds worked. You're done. Good job if you got that one.